Quantum computing is evolving very rapidly, and some say that this could break Bitcoin and the entire crypto market. So is this the time to sell all of your Bitcoin and get out of the market before it's too late? In this video, we are going to discuss what quantum computing is and whether it's actually a threat to the existence of Bitcoin and the crypto market overall. All right, we've got a lot to uncover. We're going to dive deep, and I'm going to test out a new format, which I haven't done before. And if you like watching videos like this one, if you like this channel, then make sure to hit the like button. It will help me with the YouTube algorithm to reach more people. And if you haven't done so yet, make sure to hit the subscribe button, because I'm going to be posting regularly throughout this crypto market to help you to get an edge and to help you to make sense of everything that is happening in the market right now. So let's dive in. Okay, Bitcoin is known as the most secure network in the world. It is built on an encryption standard called 𝗗𝗶𝗀𝗶. And in this video, we're going to break down what this encryption standard actually is, how it works, and why these quantum computers could potentially be a threat or not. So, as you know, the Bitcoin network, or maybe you don't know, but this is the first time you're hearing about it, Bitcoin miners are securing the network. They do this with mining machines. And all of these machines contribute computing power to the network. We call this hash rate. And as you see, over the past decade, actually Bitcoin was launched around 2009, but for the past 15 years, we see more and more hash rate being added to the Bitcoin network. So that means that we are seeing more Bitcoin miners and more powerful Bitcoin mining machines that are securing the network. Right now, we see that we have a hash rate of around 621 billion terahash per second. So terahash per second, that stands for the computing power of these machines. And it seems to be going up and up and up, meaning that there's a lot of people securing the network. And so far, it is the safest network in the world. Nobody can hack it. Nobody can hack it, and nobody can really move stuff around because there's so much people securing the network. There's so much money involved. So many people have invested, so many companies. We now see that big companies like BlackRock are also heavily getting into the Bitcoin mining space. They're buying tens of thousands, hundreds of thousands of machines to join in on the Bitcoin mining industry. Now, let's briefly talk about something that we call Moore's Law. So in technology, there is a law or a rule which was invented by a scientist called Moore. His last name is Moore, and he created the Moore's Law. And the Moore's Law is basically stating that the number of transistors on a microchip roughly doubles every 2 years, because the cost of transistors halves as well during the same time frame. So as technology progresses, transistors become cheaper and cheaper, and this allows computer chips to pack more processing power over time. So every 2 years, the processing power on a chip doubles. And as a consumer, let me try to make all of this very tangible and practical for you. For example, your iPhone. Most people have an iPhone or an Android. Over the past few years, your phone has become faster. It has a better camera. It has much heavier applications running on it. And it seems like technology is only getting better and better and better. Same with your computer. Look at the graphics that your computer or your Xbox or your PlayStation or even your television, the graphics keep on getting better. We had HD, now we have 4K. Soon we'll have 8K. And all of that is possible because of Moore's Law. Every year, every 2 years, the number of chips, the number of transistors on a computer chip double, and the cost of producing those chips also halve. And what this results in is an exponential trend up, where we see the computing power get more strong over time. So it's almost like a red line. Here in this chart that I'm sharing on my screen, you see the number of transistors on a microchip doubles every 2 years. So that is exactly Moore's Law. And here you see historically these chips that have been created, the Intel 404, all the way going up to the ARM processor, the Core. Some of these names might sound familiar to you because they are in your MacBook or in your Apple iPhone or in different devices. So as this line goes up over time, the computing power of these chips keeps on getting stronger and stronger and stronger. So how do computers actually work? Well, they work with transistors, and transistors are little devices which can either be zeros or ones. Maybe you've ever heard of the term bit. Bit stands for the way that a computer or a software processes data. Basically, it's just zeros and one. It can be on or off, on or off. So these semiconductor devices, transistors, they are on these computer chips, and they can be in a state of 0 or 1, on or off, on or off. And by combining these transistors in different configurations, you can do very complicated mathematical calculations. That's why you can run the graphics on your computer. That's why you can load your browser. That's why you can watch this YouTube video. But in the world of quantum computing, it all works a bit different. So when we go into the realm of quantum physics, we can create technology. And this happens on such an extremely small scale that it happens in very special laboratories where they have very expensive equipment that can create this technology. In the realm of quantum physics, we can create devices that are not only in 0 or 1 state, but every possible combination between 0 and 1. So there's an infinite number of states that a bit can be in. And in the quantum physics world, we call a bit a qubit, a quantum bit. So we have an infinite amount of possibilities between 0 and 1. Whereas with traditional semiconductors, and maybe you know some of the big names that produce these chips, like the Dutch company ASML, which is doing very well on the stock market, but also Taiwan Semiconductors. They're all producing equipment that are producing these semiconductors. And the next generation are these quantum machines. And now you might wonder, this sounds so abstract, Mitchell. How do these quantum machines actually look like? So in reality, a quantum computer is a very complex machine. Over here, you see Joe Biden standing next to a quantum computer. There's only a few of these computers around the world. They're very expensive, they're very power hungry, and the technology is still really developing. Over here, you see another image. It's it's a massive machine. As you can see, it's not something that you and me are going to have at home. The only use case for these quantum computers is to run really complicated mathematical calculations very quickly. Although back in the days, people would say that no one would have a computer at home, but now everyone has a computer at home. So who knows? But for now, they seem like very big, complicated, power-hungry devices. And then the next question is, how does cryptography work? So crypto, as you know it, most people know crypto from the meme coins or Bitcoin or altcoins and the crazy market swings. But if you go deep into crypto and actually try to understand the technology, it's built around the system of cryptography. Because when Satoshi Nakamoto wanted to create Bitcoin in 2008 with the vision to build a safe and secure decentralized payment network where people could transact from peer to peer, so without any intermediary like a bank or a government, he needed to create a system, and he went very deep into cryptography. So cryptography is the art and science of sending messages and data in a very secure way that cannot be intercepted, that cannot be changed, and that people cannot commit fraud. So there are a few components that are needed when you are doing cryptography. So let's say that you want to send the message hello. Hello is just a bit of data. Hello, it's letters. You could also write this down into binary form, so zeros and ones. And then you have an encryption key. So basically the encryption key is like a formula. that kind of puts it in a different form, a form that cannot be read unless you know the decryption key. So let's say that you and me, we both have a piece of paper which outlines this symbol means this. This sequence of symbols means this. This sequence of symbols means this. And when you receive my message, then you can decipher the actual message that I sent you. So in the core, that is cryptography. And for example, in World War II, Germans were using cryptography to send messages across Europe about what they were doing, their strategy, how they should position the troops. And there were whole departments set up in the UK, in the US, that were trying to decipher what these Germans were saying to each other. And in order to do that, they had to figure out the decryption key that the Germans were using. Now, this involves quite a lot of mathematics, and you don't need to go into the mathematics. But what you need to know is that you have an initial message, you have an encryption key, then you have the ciphertext, and then you have the decryption key, which can turn it back into the original message. So that is a technology of cryptography, and that is the whole foundation of crypto. That is the underlying technology. So how do we go from cryptography to the blockchain? Well, the most simple way to explain this is whenever you are doing a transaction through your bank account. So I'm just comparing this through an everyday example that most people should understand. So whenever you're doing a transaction through your bank account, two things happen. Number one, money gets deducted from your bank account and it gets added to someone else's bank account. And the second thing that happens is you pay a transaction fee to the bank for processing that transaction. Now, when you're transacting on the blockchain, especially on the Bitcoin blockchain, the same two things happen. Number one, you do a transaction, so Bitcoin gets deducted from your wallet and it gets added to someone else's wallet. And number two, you pay a transaction fee to the Bitcoin network. But who is the Bitcoin network? Those are the miners, so individuals with machines that process transactions on the network. They are basically the banking system of Bitcoin. And all of these transactions get bundled into big blocks of transactions. And those blocks of transactions get processed by the Bitcoin miners. And so in return for mining those transactions, they earn a transaction fee. And that's how the whole economy of Bitcoin mining can sustain itself, because individuals and companies are compensated for allocating their resources, especially time and money. So in order to do a transaction on the Bitcoin network, you need two things. You need a public key and a private key. You've probably heard these terms, not your keys, not your crypto. Let me quickly explain them. So these two keys, they can be compared to your bank account. So your public key, that is your wallet, so your Bitcoin wallet, which is a long string of letters and numbers, that is like your bank account number. If I give you my bank account number, you won't be able to do anything with it. You can only send me money, probably. But if you also have my PIN code or my password to my bank account, then you can start transacting. And that is exactly the same. So in order to do a transaction, you need both the public key and the private key. So how do you get the private key? Well, when you order a cold storage wallet like a Ledger or a Trezor, during the setup process, you will receive a string of 14 to 20 words. And that combination of words is unique, and that forms your private key. So in combination with your public key and your private key, you can actually do transactions. You can send funds to another wallet. Now comes a big question. How could quantum computing impact Bitcoin and the crypto market? Well, some say that quantum computers one day might be able to crack private keys. So they might run very complicated algorithms that could decipher your private keys. And with those private keys, they can then do transactions and move funds in or out of your wallet. Private keys are actually derived from your public key through a special algorithm on your first transaction. Quantum computers might be able to crack the private keys of wallets that have never done a transaction. So think of, for example, the wallet of Satoshi Nakamoto. This is not actually Satoshi Nakamoto, in case you didn't know. This is Dorian Nakamoto. This is a person that people thought was the actual Satoshi Nakamoto, but we still don't know who the original founder of Bitcoin is. Maybe he's dead, maybe he's still anonymous, maybe he understands that if he actually reveals his identity, he might be in trouble with the FBI, the CIA, all the intelligence agencies. So he is still anonymous, but he has never moved his Bitcoin, and there's around 1 million Bitcoin in his wallet. So since he has never done a transaction, quantum computers could actually go in, and through this process of reverse engineering this algorithm, they could get these private keys and they could get access to this 1 million Bitcoin potentially. That is one big hypothesis that there is in the crypto space. If this is actually going to happen, we don't know. Some people say that we will actually know if quantum computing is a mature technology when we see the first 1 million Bitcoin moving out of Satoshi Nakamoto's wallet. But according to most cryptographers, people that have used their Bitcoin that have set up their wallets and have transacted with those wallets, and people that have their own private keys in their own hands, those are for now safe from quantum computers, because there is still no quantum computing algorithm that can break 𝗗𝗶𝘀𝗰𝗹𝗶𝗺, which is the hashing algorithm, the cryptography algorithm that is at the foundation of Bitcoin. Also, it's important to understand that Bitcoin is constantly evolving. So Bitcoin has a very big community of developers, of investors, of analysts that are very heavily involved in the industry. And it's also possible to propose Bitcoin improvement proposals. We call them BIPs. And those Bitcoin improvement proposals with a majority vote from the miners can be implemented into Bitcoin. We call this a soft fork. That means when the software of Bitcoin gets upgraded. There are very few upgrades to Bitcoin. The nice thing about Bitcoin is that the software which got uploaded and created in 2009 is still the primary software that is Bitcoin right now. But once in a while, when there's something really important happening in the crypto space or in the financial markets or in general, then miners could go for a voting and they could implement updates to the Bitcoin algorithm. And one of those updates could be to make Bitcoin quantum computing proof so that people could not break the algorithm. So again, we are evolving and innovating, and we are not standing still as the environment evolves around us. Large corporations like Apple are right now also in the process of quantum proofing their security. So Apple recently announced that iMessage is now quantum proof. So their encryption mechanism is now quantum proof. And if Apple can do it, then the Bitcoin community, which contains some of the smartest people in the industry, could probably also do something very similar. So let's wrap this all up by coming with a little summary. So yes, it's true that quantum computing is on the rise. Right now, there's a lot of funding and development in that space. And quantum computers, for sure, are going to be very strong technologies that can do really amazing things, but also very harmful things. They can be used to crack passwords. They can be used to crack other encrypted messages. They can be used to get into your private messages and interfere with your life. But when it comes to quantum computing and Bitcoin, for now, there is no big threat. And Bitcoin is also constantly evolving. We've got some of the smartest people in the space, which are monitoring all of the developments that are happening right now. And we can also adopt and improve and make Bitcoin better as we go. So for now, we're safe. And I think also in the future, we will be safe from quantum computers as well. And quantum computing is still a very early technology. Right now, the best quantum computers, I believe, cannot run for more than 1 second. Of course, as this technology progresses, we will have stronger quantum computers that can run for longer and that can do more complicated mathematical calculations. But it seems like Bitcoin is safe. All right, I hope you enjoyed watching this video. I really did my best to explain this in the simplest possible way because this is such complex material. And I've spent quite a few days to research this myself to come up with a good answer to this question. And if you appreciate this video, then make sure to hit the like button and to subscribe to my channel because I'm going to be posting more regularly to give you more comprehensive tutorials and breakdowns like this one. All right, that being said, peace out, and I'll see you in the next one.